All right, properties of operations. How do the commutative and associative properties compare and contrast? So how are they similar? How are they kind of different? So that's the assumption that you know what the commutative and associative properties are, but I'm going to go over it today anyway, just in case. So let's go start with an example here. So Mr. Ramos drives up and down his street to finish errands. So here's different things that I might be doing. All right, here's my house. Here's my home. And I go up 4 blocks. There's Target. Another 2 blocks is the library. Another 6 blocks is a baseball field. So suppose Mr. Ramos drives the library from his house. How could I express that? Well, from the house to the library, I'd go 4 blocks and another 2 blocks. So 4 plus 2. Let's suppose I go back home. Well, if I go back home, I'm going to go 2 blocks and then 4 blocks. But if you notice, both of these equal 6 blocks. Okay, no matter if I go there or I go back, the order does not matter. So in this case, when I'm adding, what property am I going to use? This is called the commutative property. Commutative. So think of my commute. Okay, when your parents leave their house to go to work and they come back, they go the same distance typically, unless they're making other stops. But they'll go one way and then they go the other. So 4 plus 2 is equal to 2 plus 4. Now let's suppose that I drive from home and I go to Target and then I drive to the baseball field. So first I go to Target and then I go to the baseball field. So that would be shown like this. I go 4 blocks and then I go 2 and 6 more blocks to get to the baseball field. Now let's suppose the next day I drive to the library. Okay, so I go all the way to the library first, and then I go to the baseball field. Well, in this particular instance, I'm going to go 4 plus 2 first, go to the library first, and then I go another 6 blocks to get to the baseball field. If you notice here, I'm going to end up, if I simplified this, that would be 4 plus 8, which equals 12 blocks. And over here, that's 6 plus 6, which also equals 12 blocks. It's going to give you the same exact value, except this time I'm adding a couple other numbers first before I add the other. And so this is called the associative property. Okay, associative property of addition. So what it's saying is, look, when you're adding 3 numbers or more together, just adding stuff together, the way in which you block them up or you associate them, you say, hey, these first or these first, does not change the value. So here's the key concept: properties of operations, commutative property. Again, I'm pretty sure you've seen this before, but write it down one more time just to make sure. The order in which you add or multiply does not change the sum or product. So this works for both multiplication and addition. Well, the reason is multiplication is just repeated addition. So if it works for one, it's going to work for the other. Here's some symbols using algebra. A plus B is equal to B plus A. Shows you, hey, the order doesn't matter. And then here's some numbers just as an example. 5 plus 2, 7, is equal to 2 plus 5, also 7. Multiplication works the same way. A times B is equal to B times A. Doesn't matter in which the order in which I multiply, I will get the same answer. Okay, and then the associative property. The way in which numbers are grouped or associated when added or multiplied does not change the sum or the product. Okay, so here's your symbols and here's your example. It works again for addition or multiplication because remember, multiplication is just repeated addition. So if it works for one, it will work for the other. Symbols: A plus parentheses B plus C is equal to A plus B in parentheses plus C. In other words, hey, look, add these first and then add that, or add the first 2 and then add the last one. Doesn't change anything. And those are some numerical examples to show you that those work. A couple of other properties that I'm just going to briefly talk about that you should know about are the additive identity. Okay, identity. Identity means, hey, I want to keep it the same as where I started, keep my identity. So additive identity, when I add 0 to any number, I get my same number back. 0 plus a number or a number plus 0 gives you my number back. So here's an example. This is using the algebra and this is using numbers here. So 9 plus 0 is 9. 0 plus 9 is 9. That's called the additive identity. There's the multiplicative identity. Again, identity, key word there tells you, hey, I'm going to end up with the same answer, same number. So A times 1 equals A, or 1 times A equals A. So when I multiply anything by 1, I get my same number, or 1 times a number gives me the same number. That's called the identity, multiplicative identity. The last one I'll show you is the multiplicative property of 0. And it's basically, look, when I multiply anything by 0, I'm going to get 0. Okay, and that's some pretty standard stuff, things you've been seeing for a long time, but maybe you didn't know that there was an actual property for it. So those are the 3 properties you want to know, in addition to commutative and associative. All right, I'm going to keep your notes brief, so I'm going to just show you 1 or 2 other examples, and then in class we'll go ahead and do more practice so you get used to it. Simplify and justify. Here's the big key word, justify each step. So watch how I do this problem. I got 7 plus x plus 5, and 7 and x are in a parenthesis. So here's what I'm going to do. I'm going to change this. I'm going to reverse the order of these two. I'm going to put the x first and then the 7. And I can do that because of the commutative property of, I just put a little plus sign, of addition. Next, I'm going to group them differently. I can't take x and add it to 7. I can't do that. It's not going to give me anything because I don't know what x is so far. But what I can do is I can regroup some stuff. I can use the associative property of addition, saying, hey, look, if everything's being added, let me just add these two instead of these two. So I move the association. I then just simplify it, and that would be my final answer. I can't go any further than that. X plus 12. So some of you I know say, oh, Mr. Reynolds, I could have got from here to here without a problem. And that's fine. I understand your brain can work that way, but you need to know that there are properties involved going on in your brain that actually get you to here. That gives you the proof that says, hey, I'm allowed to get here because of this, this, and that. Okay, here's the last example. I've got 4m times 2 in parentheses times 5m. All right, so the first thing I'm going to do is I'm going to use the commutative property of multiplication. I just put a little x there to represent multiplication. All right, so what it is, I flip the order here. So every time I flip the order, I'm using commutative. Then I use the associative property of multiplication and say, hey, look, I'm not going to multiply these two together yet. Right now I'm going to go multiply 4m and 5m together. I get 20m squared, right? Because 4 times 5 is 20, m times m squared. That's simplifying that. Next, I'm going to use the associative again. I say, look, I'm multiplying a 2 times a 20 times m squared. So why don't I just multiply the numbers first together? 2 times 20 is 40, and then I simplify that. All right, and that's it. And that's how I get from here to here. Now, once again, I'm telling you, I know. You could say, look, Mr. Reynolds, I could see 4 times 2 times 5. That gives me 40, m times m squared. That's great. I appreciate that. That's fantastic. But you need to know that these are the properties that are happening in order for you to get there. Okay? So getting ready for some proofs later on. All right, that's it for notes today. Have those done and completed. If I were you, I'd get your 3 questions and summaries done now so you don't have to worry about it later. All right, we'll see ya.